Is my screen visible to all of you?
Yes.
Okay. So in last class, we are talking about some important components of the uh, hydrological cycle, and the next immediate important part which we need to consider is different sources of water from where we are going to collect the bulk amount of water which is required to distribute in a particular locality. Now for that, we'll classify the water mostly in two different categories. One is surface sources and another one is subsurface sources. Now, the surface sources, again, it can be divided into several different form. This is, we should not say this is the classification, rather we should say in different forms we can get this surface sources of water. So what are those? Number one, streams, rivers, ponds, lakes, and impounding reservoirs. So usually these are the different forms by which we can see surface waters. So we'll be discussing in detail about the surface water and as well as subsurface water sources subsequently. So coming to the first part, so that is the natural ponds and lakes. So the natural ponds and lakes, basically, if you see in mountains, at some places, natural basins are formed with impervious bed by springs and stream, that is known as lakes. Now, it is not that always a lake has to be situated in the mountains. Any area, because of the usual uh, lithosphere and the different depression in the lithosphere, we can have such kind of lakes. So the quality of the water in these natural ponds and lakes depends upon the capacity of the basin, the catchment area, annual rainfall, porosity of the ground, and what are the minerals which are actually present, as a bed of that particular lake. So that is also important, since some amount of chemicals would ooze out and get mixed with the water in the due course of time. But lakes and ponds situated at higher altitudes contain almost pure water, and it has been observed also in practical, which can be used without any treatment. And that is why most of the people, you will see that they would say that if the water is from some hill, mountain, or some lake which is situated in the mountain, so that is the purest form of water and we don't need any treatment for that. So this is you might have heard this kind of statement from local people, because they don't go for the treatment. They know that this can be the purest form of water which you can get naturally. Fine. But ponds formed due to the construction of houses, roads, railways contains large amount of impurities and therefore cannot be used for water supply purposes. Now, what happens is, lakes are a little bit, I would say, is isolated or remote in position than the human agglomeration. On the contrary, when we talk about ponds, most of the ponds are, it's artificial because of the anthropogenetic activity. So people or human being might have created ponds, or maybe uh, though it might be some ponds might be natural, but mostly you will see the ponds are close to the human agglomeration. And what happens is, because of those other activities, construction works, and mostly construction works and industrialization, we may have a lot of impurities which can go into the pond water, and that is why the quality of pond water not as good as the quality of water in case of lake, and that is why this water cannot be used for water supply purposes. It requires a rigorous treatment process before you can ensure the same quality, and which may deter the efficiency in terms of overall money involved in treating that particular water. And that is why uh, pond water is usually not preferred to be utilized as the source of water supply. Next, we are going to talk about the streams and rivers. So these are the different forms, which we are now considering here. So rivers and streams are the main source of surface, main source of surface water. Fine. So usually, this is what we say sweet water or fresh water, because the water is pure and the taste of the water is also good, and even if it contains some amount of chemicals or minerals present into it, so that is quite beneficial for our health and metabolism. So that is why they are considered to be the main source of surface water. In the summer, the quality of water is better than the monsoon, and the reason is very much well understood. And what happens is, during the rainy season, the runoff water also carries with clay, silt, other biological matter, organic matter that makes water turbid. The BOD also can get increased, and so many other once runoff is happening, you cannot control the process, so the chance of getting contaminated of that water is also high. So river and stream water requires special treatments. Some rivers are snow-fed and perennial and have water throughout the year. So any perennial river, whether it is snow-fed or not, any perennial river, the water is coming throughout the year, and therefore they do not require any arrangements to hold the water. So the continuous water flow will be available throughout the year, and from there you can directly collect the water which is required for you to distribute in a particular locality. On the contrary, some rivers dry up wholly or partially in the summer, and so they require special arrangements to meet the water demand during hot weather. You will see mostly the rivers in our country which originate from any Deccan Plateau or Somenath Plateau and then goes to the Bay of Bengal. Those rivers actually carry most of the water during the monsoon, and throughout the year we don't get water in those rivers, and that is why in these areas, mostly you will see that eastern coastal belt, I would not say purely coastal, but the rivers which are originated from these plateaux which I mentioned, you will see lot of dams and the reservoirs, because you need to have some arrangement so that you can store that water for the time when the water flow is not continuous in those rivers and streams. So that is why special arrangements are required to meet the water demand during hot weather. Mostly all the cities are situated near the rivers, discharge their used water of sewage in the rivers. That is also source of contamination, which as an environmental engineers we should keep in our mind. Therefore much care should be taken while drawing water from the river. So you need to ensure that the water which is drawn from the river is not contaminated to that extent where it becomes unhealthy or toxic or uneconomical to treat that water. So that part also should be ensured over here. Next is the impound reservoirs. So impounding reservoirs, in some rivers the flow becomes very small and cannot meet the requirements during the hot weather. So it's quite similar phenomena which we are talking about, and it has been discussed in the previous points also, when we are talking about the river where the water was not continuous during dry season. River used to get dried up. Now in this case what we are talking about is it may not get dried up, however it the flow will become significantly less, and then it cannot meet the demands during the hot weather. Now, in such cases, the water can be stored by constructing a bund where or a dam across the river at such places where minimum area of land is submerged in the water, and maximum quantity of water can be stored. So we need to select the most suitable area where this kind of structures can be constructed to maximize the storage capacity and to minimize the quantity of land which will be submerged. So these two factors becomes very important. But you know moreover, in lakes and reservoirs, suspended impurities settle down in the bottom, but in their bed, algae, weeds, vegetable, and organic growth takes place, which produces bad smell, taste, color in the water. And therefore, the water should be used after purification, right? The water should be used after purification. When the water is stored for a long time in the reservoirs, it should be aerated and chlorinated to kill the microscopic organisms which are born in the water. So that part also should be, kept in the mind. There are problems, there are advantages and disadvantages of such kind of structure. In one way, it helps in reducing the turbidity in suspended solids. On the other hand, those kind of environment is very conducive for the growth of the organic matter, and sometimes that can lead to the generation of microscopic organisms, and that can deteriorate the quality of the water. Now, with this, we'll slowly move to the subsurface sources. Now, in subsurface sources, there are few different forms which we are going to talk about. And the first one is, infiltration galleries. You might have heard of this term. Among the subsurface sources, infiltration gallery is one of the most popular way by which water is collected. So, what is infiltration gallery? Is a horizontal, nearly horizontal tunnel which is constructed through the water-bearing strata for tapping underground water near rivers, lakes, or streams are called as infiltration galleries. Fine. So the yield from these galleries, may be as much as 1.5 into 10 to the power 4 liter per day per meter length of infiltration galleries. For maximum yield, the galleries may be placed at full depth of the aquifer, and the infiltration galleries may be constructed with masonry or concrete with weep folds of 5 centimeter into 10 centimeter. So this is what actually I was talking about, and this is the schematic diagram of the infiltration gallery. So what happens is, as I was mentioning, so underground tapping is being done over here. So the water bearing strata, just beneath the natural surface water bodies, there will be water bearing strata, and if you can puncture that water bearing strata, water will come in that pipe or the conveyance system, which can be pulled out, and that is the way infiltration gallery works. So this particular system consists of several components: pumps, valves, sump, and then you have pump and you have discharge pipe, and at the same time you have the infiltration galleries, which is horizontal most of the times, and it is actually kept in the full depth of the aquifer, so as low as possible, so that you can take the maximum amount of water during the summer days also. Fine. So if there is a network problem, and if you are unable to hear, any of the seer can call me immediately. I'll again rejoin. But you don't wait. Next is infiltration wells. So this is also one sort of formation which we are talking about, and in these, in order to obtain the large quantity of water, the infiltration wells are sunk in series in the banks of the river. Right? The wells are closed at the top and open at the bottom, They are constructed by brick masonries with open joints, as you know. Can you can see this in the next slide. Now, for the purpose of the inspection of well, the manholes can be provided at the top cover. So we'll go and see this. Here you can see which I was talking about. So what is the you know, the open joints will be there, and then we will have pipes from different infiltration wells which will come to the jack well. So you see the jack well in the left hand side, we have that realistic photo, and in the right hand side we have that schematic of that. Now once we have that river and stream, so we can have infiltration well, and from that infiltration well it will be connected to the jack well, and the water which will be accumulated in the jack well will be taken out by the help of pump. So this is the overall infiltration well structures. And you can see here we have shown the jack well infiltration wells, and the pipes which connect the jack well and infiltration well is also shown over here. Now always manholes are placed. You can see in the top right hand side photo that we have indicated the manhole is provided in the top cover to inspect those wells. The water filtrates through the bottom of such wells, and as it has to pass through the sand bed, it gets purified to some extent, and the infiltration well in turn are connected by a porous pipes collecting sump called the jack well, and then the water is pumped to the purification plant for the further treatment. So this is the overall way by which these infiltration wells work. Next is springs. So sometimes groundwater reappears at the ground surface in the forms of springs. How we are going to talk about them? Springs generally supply small amount of quantity of water, and hence suitable for small towns. Mostly in the hills, you will see that springs are very good source of water, fresh water. Some springs discharge hot water due to the presence of sulfur, and useful only for the curing of certain skin disease patients. So basically, the springs which we are getting that might be hot sometime, and that is why you might have seen heard about hot spring. So this is nothing but one type of spring. From here, the hot water is yielded. Now, what are the different types of springs? So the first one is gravity springs. Now, what happens in case of gravity springs? When the surface of the earth drops sharply, the water-bearing stratum would get exposed to the atmosphere, and gravity springs are formed, as shown in this particular figure, which is placed in the bottom right-hand side corner. You can see what has happened is we can see a sharp drop in the earth surface. However, the water bearing strata or the groundwater table is suddenly get exposed to the atmosphere, and this can create springs, and this is basically known as gravity springs. Next, which we are going to talk about here, is the surface springs. Now, surface springs, this is formed when an impervious stratum which is supporting the groundwater reservoir becomes outcrops, as shown in this particular figure. So what happens is, there is an impervious stratum at the bottom, and that impervious stratum is actually supporting. On the other hand, if you see, like I have drawn here another one layer, so you can have such kind of impervious layer also, which can get sandwiched between the two aquifer. And what happens is, if there is a sharp drops, and at the same time the impervious strata get exposed, then in that particular joint you can have a spring, and that spring is known as surface spring. And we have that impervious strata which has been shown here. Next one is very interesting, that is the artesian spring. When the groundwater rises through a fissure or in the upper impervious stratum, then it is basically known as artesian spring. So there are many ways artesian spring can happen. Here we have shown artificial artesian spring, or in this case we have created structures where water is actually stored, and from the bottom you can see over here, just let me show you. This is the fissure through which the water is coming. Fine, might be in somewhere the height of the source is higher here, and then because of that through the fissure water is coming and then getting yielded over here, and it is getting stored by creating a structure. Now then if you create such kind of facilities, so the water will continuously flow. So this is one type. Often we see natural artificial springs. So that has been shown in the right hand side. This is what actually I was talking about. Suppose the aquifer starts from the ground surface and then it goes beneath the ground surface, and if there is a sudden or sharp drops of the ground surface in somewhere, so what happens is, in this case the ground surface meets the upper boundary of the aquifer, and then the aquifer get exposed, and once the aquifer get exposed it creates a spring, and that spring is also known as artesian spring. Now when the water bearing stratum has too much hydraulic gradient and is closed between two impervious stratum, the formation of artesian spring from deep seated spring also happens. Fine. So the head would be here, if you see that the hydraulic gradient would be very high, fine, very high. So as soon as water comes through this, and then to maintain the same height, water will start sprinkling out, and you will see this kind of formation in the nature in many places, and usually those places are very popular and people visit to see such kind of natural formation to watch. Often in Indian culture they are considered as very holy or something, so you can visit such kind of hot spring or artesian spring or surface spring in many places. You can see mostly in the hilly regions. Okay, so now we'll be talking about the wells. So another one source of water. Well, so till now we are talking about surface and subsurface. So now we'll be talking about wells. Now first let us define what is well. So a well is defined as an artificial hole or pit made in the ground for the purpose of tapping water. And in India we have 75 to 85% of Indian population who depend on the wells for its water supply. So many of you might have seen different diameters of well in Bihar and Jharkhand, these regions, and as well as in the upper part of Odisha, and as well as in the Andhra Pradesh, Telangana. We see so many wells, and most of the peoples meet their water demand through these wells, and they can get water throughout the year. Now there are three factors which form the basis of the theory of wells: are geological conditions of the earth's surface, porosity of various layers, and quantity of water which is absorbed and stored in the different layers. So they can directly be related to the the theory of wells and how we are going to yield, how much we are going to yield, those things. Now the following different types of wells can be found naturally. Number one, shallow wells, deep wells, tube wells, and artesian wells. Now artesian wells also are the type which we need to discuss in detail, so we'll go and discuss them subsequently. Now shallow wells, so from the name itself we can understand that the depth of the well is not very deep. It is quite shallow, and within 2 to 6 meter from the within 2 to 6 meter is the diameter, and the depth can be again 6 to 7 meter maximum, not more than that. Now shallow wells may be lined or may be unlined, so that depends upon what kind of geological structures are present over there, what is the type of soils or geomaterials which are surrounding this kind of wells. So if it is having enough strength to hold it at 90-degree cart, then we need not to provide any lining. So that is why in both way you can find lined shallow wells or unlined shallow wells. In the figure we can see here that lined shallow wells. And now these wells are also called as draw wells or gravity wells or open wells or drag wells or percolation wells. So there are so many different names by which we can call them. So that staining thickness is also given in the diagram, so you can go through that. We'll go to now with a few more features of shallow wells. The quantity of water available from shallow wells is limited from the name itself, and the way this water is getting accumulated in the wells. From there, you should be able to understand that the overall quantity of water is not huge, and it's quite limited, as the source of supply is in the uppermost layer of the earth only, and sometimes may even dry it up in the summer. So this part you need to keep in your mind, hence they are not suitable for public water supply scheme. So if individual one family wants to utilize this kind of facility, it's good, but you cannot rely upon such kind of sources for public water supply scheme. Now the quantity of water obtained from shallow wells is better than the river water, but requires purification depending upon the quality, final quantity, the quality which you get after characterizations. The shallow wells should be constructed away from the septic tanks and soak pits, because there is a chance of contamination of effluent. If you can, if you construct shallow wells and soak pits or septic tanks in the same depth, then there is a chance that all of them are going in the same aquifer which are connected to each other, and by that there is a chance of getting contaminated effluent mixed water from the well. So this should be avoided. But the shallow wells are used as the source of water supplies for small villages, undeveloped municipal towns, isolated buildings. That is what actually I was talking about. Mostly in case of isolated buildings, shallow wells are a very popular source of water of limited supply and bad quality of water. So these are the so basically for individual houses, shallow wells can be considered as an alternative source of water. So there might be a steady source of water, and whenever you are not getting water from that, or whether you are unable to meet the demand at your home, then you can take the extra water from this kind of well. So this is the main philosophy behind constructing shallow wells. Now next comes the deep wells. So usually the deep wells obtain their quota of water from an aquifer below the impervious layer. So will be, if possible, I'll show some photo of this. Now the theory of deep well is based on the travel of water from the outcrop to the site of deep well. So the entire characteristics of the deep well, or the success or the efficiency of the deep well, depends upon depends upon these factors. So basically the outcrop positions, and how water are traveling from that outcrop to the deep well, those things are very important. The outcrop is the place where aquifer is exposed to the atmosphere. So in the previous you can see, so this can be called as outcrop. I'll just show you in the, yeah. So here if you see, this is the portion which is known as outcrop, because aquifer is getting exposed to the atmosphere over here. So similar thing we are discussing, we should be able to get those things to have a very good deep wells. The outcrop is the place where the aquifer is exposed to the atmosphere. The rainwater entered at the outcrops and gets thoroughly purified when it reaches to the site of the deep well. So what happens is, while it is percolating through the aquifer, through the formation, it's getting purified to some extent, and when it reaches to the mm, deep well site, by the time most of the purification would be completed. Now, but it dissolves certain salts and therefore become hard. So that is a main problem with any groundwater you consider. So while traveling from that point to the deep well site, it can contain some amount of salts, and that some form of salts which actually increases the hardness of the water, and that is why it can become hard. So in such cases, we need to have pressure treatment to remove those hardness which we have discussed previously. Now the depth of the deep well should be decided in such a way that the location of outcrop is not very near to the site of well. So if it is far from the site of the well, then the chance of getting good water will increase. Now the water available at a pressure greater than atmospheric pressure, so therefore deep wells are also referred as the pressure well. So what happens is, in this case, the water will be having pressure more than the atmospheric pressure, and here actually I have given a schematic diagram, and we'll try to show you all different type of wells. Now you can see here that we have this water table, and this is the impermeable part. This area, just let me put it in laser modes. This is one impervious layer, this is another one impervious layer, this is another one impervious layer. So this is the unconfined aquifer, and this is the confined aquifer, and here this part can be considered as outcrop. So the same aquifer has gone up. Now this is the water table, so atmospheric pressure will exist over here. Now here where we would have more pressure than the atmospheric pressure. Now there might be different type of wells, and all the different type of wells have been shown over here. Artesian wells, we have flowing artesian wells when the head is more, so there is a chance of. Then another one is parched aquifer water table and parched water table well. So when there is an isolated portion where water has got stored, you can see that what has happened is bowls kind of formation has been created over here. We have an impervious layer, and at the top of that we have a formation which can hold the water, and if you simply puncture that up to that particular level, you will get some water. So that is known as parched water table well. On the other hand, if you simply reach to the unconfined aquifer, and then if you try to take out the water, so it will be water table well. And if you reach to the confined aquifer and take out the water, so this is basically artesian well. And if there is a depression or sub drops in the ground surface, what will happen is, because of the pressure, the water will start sprinkling out, and this is known as flowing artesian well, which can be shown in many places in our country also. Fine. So the next part, which is very important, is the factors governing selection of source of water. So there are several factors on which this particular which source we should consider depends upon. The first one is the quantity of available water. The quantity of available water at the source must be sufficient to meet the various demands during the entire design period of the scheme. Sometimes the water sources may be mobilized for the present day demand, and the water and extra units added with the passage of time. So that depends. What happens is, after you go for this population forecasting, and you understand that right now providing that much infrastructure or constructing that much infrastructure is not economically viable. So right now you do just to satisfy the demand, and maybe keep provision to construct something after a couple of years to meet the demand, that point onwards. So that kind of stage construction also are planned sometimes to efficiently utilize it, to efficiently maintain the cost of the overall project or overall scheme. If sufficient quantity of water is not available in the vicinity of the area, we may have to think of bringing water from a distant source. So that is why quantity of available water is the most fundamental characteristics to choose a particular source of water. Next, important one is the quality of available water. So the quality of available water at must, it should not be toxic, poisonous, or injurious to health, which we can say hazardous. So the impurities present in the water should be as less as possible, and it should be near to the permissible limits, so that you can minimize the cost of treatment, and by the normal economical treatment methods, whatever impurities are present can be eradicated. So that is why quality of the available water also should be considered a very important factor. Now, the quality standards required for public water is mentioned previously, and we can tally with that to understand a particular source whether that is suitable for providing water to the public supply scheme or not. Third one is the distance of the source of the supply. So the source of water must be situated as near as the agglomeration where we are planning to adopt that particular water supply scheme. Because when the distance between the source and the city is lesser length of pipe conduits and fewer number of associated appurtenances are required, and that would significantly reduce the cost of the overall project. Now, the general topography of the intervening area. So the area of the land between the source and the cities would be highly uneven. Should not be highly uneven. There should be a natural slope, and that would help you to take that water, and you can reduce the cost of pumping also if you have such kind of terrain. However, if it is very the uneven, and then it is really difficult, and that would increase the overall cost of the project. In other words, we can say that it should not contain deep valleys or high mountains. So then there will be a question, how to pass if you get such kind of formation. So that part also needs to be planned. In such uneven topography, is the cost of the terrestrials for carrying water pipes in valleys, or the cost of constructing tunnel in case of mountain, would increase enormously the overall cost of that project. So we need to think on these aspects. Next is elevation of the source of supply. So the source of water must be at the higher contour, lying sufficiently higher than the city or the town to be supplied the water. And by that, what would happen is, only by gravity flow, we can take the water from the source to the treatment, and as well as in the supply area. And when the water is available at lower levels, then the average city level pumping has to be restored, and that involves huge amount of operational cost, and there is a possibility of breakdowns also. But if you construct something which works naturally by the help of gravity, then you can ensure of getting uninterrupted water service throughout the year. So that is why elevation of the source is also important, and considering all these factors, one should choose a particular type of source which can be considered for a particular water supply scheme. So with this, we'll stop today.